Hey guys, this is Jeffrey. I'm here with a video on inheritance and polymorphism. So inheritance and polymorphism together are fairly simple topics. Inheritance is a way of writing a class that can extend the functionality of another class, and polymorphism is the way of overriding methods in a subclass, a class that inherits from another class, to change the functionality. So for an example of this, I've got two classes here, parent and child, just to illustrate more clearly the inheritance going on here. And what happens is, in the child class, my first line is public class child extends parent. This extends keyword here says that it is going to be inheriting from parent. So in Java, what it means to inherit is that anything declared as public or protected inside the class it's being inherited from is going to be defined the same way in the child class. So for example, in parent right here, I've got these two strings, public string, protected string. Both of those strings can be referenced from the child class as if they were declared in the instance variable field of that child class. Methods are also inherited the same way, that any public or protected method from the parent class can be accessed from the child class. But notice here you can overwrite a method. The override annotation here is not necessary. It just it's a nice coding practice to have. You don't need it. It'll still work fine if you don't have it. But what you do if you override something is you're taking that method from the parent class and you're giving it a new definition. So in this case, public method is going to print out this method is super, and in this case, it's going to print out this is the child's overridden public method. So it changes the functionality of the method, and that's called polymorphism. So to kind of give you a good example of this, I'll run this code here, and you can see the chain of execution starts with parent.public method, and since that method is public, it can be seen from anywhere, and it's just going to print out this method is super, as you see right here. Protected methods work mostly the same way. The protected keyword in Java means that the item that is declared as protected can be seen by anything in the same package. So since in this package right here, all these classes are in the same package, any of those can access this protected method. In most other languages, protected will mean that it can only be accessed by subclasses. That's not the way it works in Java though. Protect can be accessed by anything in the same package. But notice, however, that I cannot make a call to the private method because the private restricts visibility to only this class in itself. So if I were to put a line of code in the instructor that said, for example, there was a call to private method, it would print that out. Like if I did something like this, it would print out this is a private method when I run the code. Whoa. Oh, right, forgot to uncomment that, or to comment it again. It'll print out this is a private method, but it only is going to do that if it is called from inside this class. So that's kind of how that works. But to go back to the execution, the next point in main, it's calling a child. This child here is just told to print out the data it can see. So in the method printData, it's able to print out public string and protected string, which are defined in parent, because since the child is a type of that parent class, it is able to access those instance variables that are declared as protected and public in the parent class. Note here, there are two constructors. I use the default constructor in this case. So this string new data has a value of default. That's why I printed out that way. And then I went through and printed out the calls to the local public, private, protected methods here. And that is where you see this. This is right here where polymorphism comes in. You'll see that it's calling the child's version of this method as opposed to the parent's version, because this call occurred in the child's class. However, if you do super dot public method, that is an explicit call to what is in the parent. So you see that super dot public method does not reference this method here. It's actually going to reference this method right here, because it's the method in the super class. So super dot that method will print out whatever the super class would do there. So, and that's really all that polymorphism is. It's just saying you can redefine methods and then you can choose which one you want to run. And then going back to main, the last example I've got here is printing out for a second child object. This one I'm using the second constructor. This is called overloaded constructors. It's just a term for saying you've got multiple constructors that have different parameters. So in this case, I'm using the super keyword right here in a different way. In this case, super is a call to the parent constructor. So instead of having to rewrite in this class instance variables for strings A, B, and C, I can just say, hey parent, take care of that for me. And in parent, it's going to assign all those values properly, rather than having to do that again and again in every child class. And then you can also accept new data in that constructor and simply assign it the way you would assign any other data. One very important thing to note is that there is in every constructor a call to super. In this constructor right here, this public constructor with no parameters, it is actually identical to writing this. When the compiler runs through this, it automatically puts in a call to super at the beginning of every constructor, unless there's one that's already there. So notice if I take out this public default constructor, the one with no parameters in parent, and I go back to child, that call obviously doesn't work because there's no longer a default constructor in parent, so you can't call with no parameters. If I take this out, this still throws an error because the only type of reference to super that the compiler puts in is one to a default constructor. So if there's not a default constructor in your parent class, you must have parameters being passed through super, and you must explicitly say that you're using super, or otherwise you're going to get an error. So that's just something important to be aware of. That's something the AP test loves to go over. So to head back here, the next thing you can do with inheritance and polymorphism that's a little bit more advanced is using abstract classes. Abstract classes are classes that can never be instantiated, but they simply serve as classes to be inherited from by subclasses. The only purpose of an abstract class is to have something extend it. So if I go to parent right here, and I declare parent as abstract, now this class cannot be instantiated. You see it's going to throw an error where I try and instantiate that parent. So I'm going to comment that out. And then you notice right here you can have something called an abstract method. The purpose of an abstract class is often to have abstract methods that will then be implemented by child classes. Any method declared as abstract must be implemented by every child class. And you declare an abstract method simply by saying abstract as one of the keywords in the header, and then a semicolon instead of the method body. Since abstract methods don't have method bodies, you don't need the braces there. You just put the semicolon. So in child here, this class would actually not be allowed to run properly unless you implement that abstract method, or you declare this child class as abstract also. However, chaining abstract parent class to an abstract child class is kind of rare. You don't often need to have multiple abstract classes in the same inheritance tree. So right now this will work properly, and when it's run again, everything's going to go out properly, except notice of course that you don't have an object of type parent. One last thing to point out, just because you can't instantiate a parent does not mean you can't give the type parent to something. Notice that if I say parent child 0 equals new child, this declaration is actually perfectly valid. because since a class of type child is also of type parent because it's extending it, this will work. The important thing to remember here is that the child class is a type parent and it's also its own type. It has two types. So you're allowed to do this. And now child 0 is in terms of the compiler a parent. So notice right here, I'm calling print data. Print data is defined perfectly in child. It's right here. But I told the compiler that this child should be treated as a parent for right now. So what's actually happening is when it's calling print data, the compiler is saying, wait, what are you doing? There's no print data in this parent class. And that's the really tricky thing about inheritance and polymorphism, is that you have to know that whatever you say, whatever type you give it, when you declare it, is going to limit the types of methods you can use. So in this case, I can't call a method in child that doesn't exist in parent. And notice what happens if I call a method that exists in both of them. When I print this out here, let's see. Right here, let's make this a little bit more obvious. Comment out anything I don't need. There we go. So child, when it says child.public method, it's still calling this child's overridden public method. Because when it goes down to actually running the code, it knows the type that this actually is. It's actually a child, even though the compiler thinks it's a parent. It's kind of a weird thing in Java that the compiler is not as smart as the interpreter. But just something good to be aware of. The AP test loves to test that theme. So just be aware of that. The last thing I want to go over is a final class. A final class cannot be inherited. So if you do final abstract, that's an oxymoron. In coding, you can't have something both final and abstract. You would have to get rid of that abstract right there. And final means you can't inherit from it. Oh, I should probably get rid of that code. So what happens here is if you that any reference to child and even the child class that extends parent is not valid, because final says don't inherit, don't extend this. If you have a final method, that method cannot have the same inheriting functionality as a normal one. For example, if I were to take out the final keyword here, but to make this public method final, and then go down to child.java, it's going to throw an error. You can't override a method declared as final. Just as for a regular key, that's the problem. For a final, like a constant, you can't change its value. You can't change the value of a final method, and you can't extend a final class, because that would be adding functionality and therefore in a sense changing its value. So that's really all there is in terms of inheritance and polymorphism. It can be kind of tricky. I advise you guys just kind of work over it slowly. You'll get it. It's not that bad once you understand it, but it can seem like a lot at first. So yeah, that's it. Thank you for watching.